What's up, people? Okay, here we go. We're back. 4 days off. Man, I gotta quit doing that. Been busy, got my new motorcycle, and been trying to get it registered. And wow, it's already 3:23. That's insane. Can't believe it's that late already. But, alright, so let's pick up where we left off. We forgot to finish our devlog from the last time. So we did, actually that's 2 plus 1, so we did 3 hours that day. Okay, there we go. So let's read our devlog from last time. I did a quick playtest. We continued creating pseudocode for client overall logic restructuring for reconnect system. Then modified both server and client such that we have one client file client instance and improved the associated logic in server, wherein we have a new server client class which is instantiated 2 times in server, one for each client. We did that to reduce bloat, or I guess you could call it bloat. Tested via game test. After alterations, everything is working as it was, 100%. Cool. So then we have roughly an hour of continued implementation of the reconnect system, whereby we created client refactor pi and began making first pass iteration of this new system. And then we stopped at line 336 in client refactor. Alright. And then we attempted to stage commit and push changes, but we encountered a bug while trying to run git add, wherein it said error corrupt loose object. And how do you only stage things that are, or how do you only commit, well, no, staging, yeah. How do you only stage things that have been changed? Python git. What is the command to stage only the files that have been changed? I know that git add dot stages everything. So what stages only what's been changed? To stage only the files that have been changed, excluding new untracked files. You can use git add -u. Explanation: git add u stages modifications and deletions. But excludes untracked files. New files not yet added to git. This is useful when you only want to stage changes to files already being tracked by git. If you want to stage changes to a specific file, you can do. If you want to stage all changes, is there any reason to not use git add? Risk of overwriting files in remote repositories. Ooh, I forgot to set my timer here. Silly. So it's been 6 minutes, so we'll set it to 62. Alright, there we go. Alright, the timer's set. The timer is set, baby. Let's see if it's working. So it's been 6 minutes, so we'll set it to 62. Alright, there we go. It's been 6 minutes, so alright, so we have risk of overwriting files in remote repositories. If you stage and commit unintended changes using git add dot, you risk overwriting files in the remote repository. You risk overwriting files in the remote repository during a push. It's going to especially be problematic if the files staged are critical configs or scripts. Best practices: instead of git add dot, use git add dot key patchment so you interactively choose which changes to stage, viewing, or committing. Use git add specific file or directory. Add only the files or folders relevant to your current task. And then it's also git add q. This stage only modified or deleted files, skipping untracked files. Use git add. It's okay to use git add when you're confident all the changes in your working directory should be staged. Working on a small project or in a branch where precision isn't as critical. In short, while git add dot is convenient, it can lead to unintended consequences. Use it carefully and consider alternatives for better control over what gets staged. Tracked versus untracked. The difference between tracked and untracked files in Git lies in whether Git is currently managing the file's changes. So tracked files in Git lies in whether Git is currently managing the file's changes. Track files that are already being managed by Git. These are files that have been added to Git at some point using git add, exist in the repository's history. States of tracked files unmodified. The file hasn't changed since last commit. Modified, the file changed but not yet staged. Staged files change have been staged. So there's U, M, and S. Okay. Examples: a file that you've already committed. Git add file.txt. Git commit added file. Text after this file text is tracked. Untracked files. Files that Git is not yet managing. These files exist in your working directory but haven't been added to the staging area. Not part of the repository's history. Untracked files will not be included in commits unless you explicitly add them using git add. How to identify untracked files. So run git status, you'll see something like untracked files. Use git add file to include in what will be file text. Create a new file but don't stage it. Go hello world. Text git status. The file will appear as untracked. Managed by git. Yes, no. Included in commits automatically if modified and staged. Output. Changes to be committed or changes not staged. Untracked file. Whereas git add only for changes, modifications or deletions. Yes, to start tracking. Track files. Git is already managing those, so you're responsible for staging changes as needed. They won't be part of commits unless you explicitly add them. This prevents accidentally including temporary files in your repository. So we have tracked files is file text, track the file, add file text gets changes to be committed in file text. Git commit -m after this git file becomes tracked. Okay, I understand that. So if a file is tracked and you don't stage it using git add -u or git add dot, then when you run git commit, nothing will actually happen. Exactly. If a file is tracked but not staged, its changes will not be included in the commit. However, the commit can still proceed, it just won't include those specific changes. Tracked file with changes but not staged. If you modify a tracked file but don't stage it with git add, git knows the file has changed but won't include the changes in the next commit. Modify a tracked file, so we have new content tracked file, git status, changes and not staged for commit. Modified tracked file, if you commit now, git commit -m on branch main, nothing to commit, working tree clean. The commit will proceed, but the changes will not be included. Track file with stage changes. If you stage changes, git add. Include tracked file changes. Scenario 3. New untracked file are ignored unless you explicitly add them using git add dot. Tracked files are ignored unless you. Okay, yeah. Touch new file. Git status. Okay. Running git commit at this point will not include new file text unless you stage it first. Right? Git commit is only what has been staged. Modification to track file. Nothing to commit if there are no stage changes at all. So when did report nothing to commit? When you commit without staging. Okay. It'll say nothing to commit. If you don't stage change, nothing comes with changes when you run git commit. Always stage your changes with git add or git add them to be part of the commit. Okay, so the reason for this, I suppose, is to make it so that you can pick and choose which tracked file changes you want to commit if you want to make two separate commits for two sections of changes you made to a project. Exactly, that's the primary reason for this behavior, and gives you fine-grained control over what gets included in each commit, allowing you to group related changes into meaningful commits. If you worked on two unrelated features or fix this in a single session, you can stage and commit the changes for each feature separately. This results in atomic commits that are easier to understand, review, and roll back if necessary. Avoid accidentally committing incomplete or unrelated changes. Sometimes you're halfway through a task and want to commit only part of your progress, while leaving other work in progress changes untouched. Two sets of changes. Imagine you've modified two files in your project for different purposes. You fix a bug in bugfix.py, and then we add a new feature in feature.py. Without staging selectively, both sets of changes would end up in the same commit, making it hard to understand the purpose of the commit later. So you make changes to both files. Gotcha. Changes not staged for commit, understood. Stage only bugfix, git add bugfix py. commit the bug fix, commit m fix bug and bug fix, and then stage feature pi, get add feature pi, commit the new feature, get commit m, add new feature and feature pi. Benefits of this approach: cleaner commit history. Your history now shows 2 commits, each with clear and focused purpose. So it says xql fix bug in bug fix, add new feature in feature pi. Teammates can review changes separately, understanding exactly what each commit does. Rollback safety: if the new feature introduces a bug, you can easily revert just the feature commit without affecting the bug fix. Ah, okay, so that seems to be really the most like important aspect of that atomic commits. So I need to really work on that on doing atomic commits, because currently my commits are more just like straight entire devlog. You know what I mean? I'm just basically using Git as a backup save. My Git repository as like a save file for my project, as opposed to really like true to what the intention of Git is supposed to be, you know, in relationship to working on a project, how it's intended to be used. Use git add p patch mode to stage changes interactively. Git add p patch mode. Git add p. Git will show you each change in a track file and ask whether to stage it, skip it, or split it. Perfect for staging specific parts of the file. Specific parts of a file? The ability to stage changes separately is one of Git's most powerful features. It lets you create clear atomic commits, making your version. Explain. Git add -p a bit further, please. To stage it, skip it, or split it. Git add p patch mode is a powerful tool that allows you to stage specific parts of changes in a file interactively. This is particularly useful when you've made multiple changes in a file but only want to commit certain parts while leaving the rest for later or for another commit. It splits the changes in a file into hunks, small chunks of changes. For each hunk, it presents you with options to decide how to handle it. You can stage individual hunks, skip them, split them further, or even edit them before staging. So you run git add p, it will show you the first hunk of changes in a file. A hunk typically includes a few lines of context around the changes. For each hunk, Git will prompt you with the following options: yes, no, Q, A, D, S, S for split. So yes, no, I don't know what Q or A or D is, but then you have split, and then E. E, I guess, is edit, question mark. So stage this hunk is yes, skip this hunk, leave it on a stage, quit the patch mode, stop reviewing hunks, which is Q, stage all remaining hunks in the file without asking further. Skip all remaining hunks in the file without asking further. So D. Split, S is for split this hunk into smaller pieces if possible. E is edit this hunk manually before staging. And then display a help message with these options. So modify a file. So we have example function, old line, new line 1, new line 2, run git add -p. Git shows diff get a file pi b file pi a file pi and then b file pi 1 4 plus 1 5 old line plus new line 1 plus for a new line 2. Stage only the first hunk. New line 1. Press S, split the hunk. Get attempts to break it into smaller pieces. Press S to split the hunk. Get attempts to break it into smaller pieces. Split into 2 hunks. 1, 4 plus 1, 4. I feel like this is the line, right? 1, 2, 3, 4. I'm just sort of confused about how this works exactly. Plus 1, 4. So it was plus 1, 5, but now it's plus 1, 4. So I'm assuming this is the line number. And then you have this new hunk, which is 2, 4, 3, 4. It's like coordinates or some shit. Choose Y to stage the first smaller hunk, new line 1. And N to skip the second hunk, new line 2. Check the status, get status, new line 1 is staged, new line 2 is still unstaged. Benefits of get add P fine grained staging, staging only relevant parts of your changes for a focus commit. Helps you carefully review what you're staging, reducing the risk of accidentally including unwanted changes. You can group changes logically, even within the same file, for clean and meaningful commit history. Flexibility with edits. The E option allows you to manually edit a hunk if get's default split isn't perfect. Once you use changes in the same file, when you want to stage partial changes for atomic commits. Stage partial is when you're preparing commits for request or code review, ensure clarity. Would you like to have deeper into any of these options? What are the numbers? -1, 4, -4, and then +1, 4. What does... Oh, why did I do that? So that's apparently a chat GPT command. I didn't know that. Triggered out. The in get diff output is called a hunk header, and it provides context about where the changes in that hunk occur within the file. So we have the start count and then the start count. So start count describes the line numbers in the original file before the change. Describes the line numbers in the original file before the change. Start the number where this hunk starts in the original file. Count the number of lines affected in the original file. Plus start count describes the line numbers in the new file after the change. Start is the line number where this hunk starts in the new file. And count is the number of lines in this hunk new file. So we have -1, 4 plus 1, 5. So -1, 4 is the original file starts the hunk at line 1 and includes 4 lines. 1, 2, 4. Before the changes, this hunk spans lines 1 through 4 in the original file. And then the new file starts at line 1, it includes 5 lines in the new version of the file. After the changes, this hunk spans 1 through 5 in the new file. And new counts may differ. If the lines are added or removed, the count values for the original and new may differ. Example, line added. The original file had 4 lines in the hunk, the new file has 5 because the line was added. The hunk includes unchanged lines. Run the extra changes to help you understand where the change occurs. Oh, old line, print. Old line is unchanged, so it's included for context. Line removed, so then we had 2, 5, and then 4. Starts at line 2, and the original file includes 5 lines. Starts at 2, in the new file, the line includes 4 lines. A line, print line 2 is removed, so the count decreases. Provides the hunk header useful locating it helps pinpoint where in the file the changes occur. So when reviewing diffs, especially in large files. Partial staging NIP, the header shows which part of the file you're working on for better context. Patch files. When applying or creating patches, the headers guide Git on where to apply changes. But in the first example, there was how many? Like the line number didn't match. It was 4 lines, but 1, 2, 3, 4. There was only 2 lines context of old code with 2 new lines. It doesn't seem like the numbers matched. It said -1, 4, -1, 4, and then +1 and +1, 5, but shouldn't. I see modifiers. Let me clarify why those numbers appear the way they do, how they actually make sense. So it comes down to how Git hunks and line counts are structured. So it had 4 lines. Now let's break it down in detail. Hunk context 1, 4, 1, 5. In the original file, before the changes, the hunk starts at line 1. Okay. The hunk spans 4 lines in total, which includes both unchanged and changed lines. So we have line 1, def example function unchanged. Okay. Okay. Oh. New file. The hunk starts at line 1. The hunk now spends 5 lines, accounting for the added lines. Change here. Oh, so it's just a blank line. It doesn't even say that. It doesn't like. What does it say? Line 5, which you would include. While the numbers seem off, at first glance, long numbers are like off. Directly match the number of visible lines. However, Git is reporting the total number of lines within the effect range, including contact line, and any lines added or removed. Original file spanned 4 lines before any new lines were added. The new file now spans 5 lines because 2 lines were added. That still don't make sense. It includes context lines in both the old and new. That includes lines of unchanged context to provide helpful surroundings for the changes. The difference between that change If the old file spanned 4 lines, the new file spans 5, it indicates that one additional line was added. The numbers of show only change lines that show entire hunk range. If just a couple of lines are added or removed, Git will report the range of all lines in the hunk, both changed and unchanged. Without context, if Git only reported the actual changes, the hunk might look like this. 32. But this wouldn't be useful because you'd lose important context, like what comes before or after the changes. Yeah, sure. But I still don't like. It's didn't really make complete sense to me, honestly. Like, I think that ChatGPT was just wrong here. If I'm honest, I think ChatGPT was I called him lacking. Maybe, I don't know. Okay, so that's enough of that. I just saw it and I was like, let me learn this real quick. So our extensions are good. So before we do anything, let's run a quick playthrough. So here we go. We have M and J. And you can hear double because it's happening on both of the client side and server. Well, it's happening on both clients, so it's kind of like one of them is a little delayed compared to the other, I believe. Okay, so he got his red 3 and his 6, etc. And now he's got his 10. And so now Jay's going first. He draws from the stack. He's going to play cards. He's going to try to play everything real quick. See if this works, which it usually doesn't because that calculator for the score is bugged right now. It's easily fixed. I'm just not like worried about it right now. So we're gonna add the wild card to the 4. No, I don't like the 4s. So we'll add them. So we're gonna add this one. We'll add the 2. So it added it to the king, and it says we have negative 75 points, but that's not true. That should actually be 40, 50, 70. So that actually should have been a successful meld, but because of the bugged nature. Alright, so there, it looks like it works fairly well. So we can kill the server and the 2 clients. Alright, so now let us pick up where we left off. So we stopped at line 336 in client refactor. Well, actually, I feel like I should probably take care of this git bug. So let's try this. Let's do git branch. We have a secondary. So let's do git add underscore u. So this should commit, or stage rather, all tracked files. It says error corrupt loose object. Loose object stored in git objects is corrupt. So let's ask Chibbity Jibbity about this and see what it has to say. The error indicates that one of your git objects, specifically loose object, is corrupt. The object is stored in the git objects directory and is part of the git database that tracks your repository's content. Corruption can happen due to disk errors, abrupt power loss, or other issues. Git uses objects to store the contents of commits, trees, blobs, file data, etc. A loose object is an individual file in the git objects directory. If one of these files is corrupt, Git can't properly read or write history, which results in this error. Steps to fix the issue. Here's how to troubleshoot and potentially recover from this issue. So we have to verify the repository, run the following command to check for other potential issues in the repository. So git fsck. So git fsck, and I don't know what that stands for. So it's finding various corrupt or missing objects. Okay, so there's actually a bunch of them. Oh man, it's a lot. Why is this? I don't know. Okay, so let's see, what did it do here? It found these corrupt or missing objects in the git objects, and then it checked the object directories, and then it checked the objects, and then it says dangling blob, missing blob. Okay, missing blob, dangling tree, missing blob, dangling blob, missing blob, missing blob, dangling blob. Whoa, man. Dangling blob, missing blobs, and dangling trees. Okay, so what is a dangling blob and what is a missing tree? So for that script, they will also be listed here. Try to remove and refetch the corrupt object. If the corrupt object is a commit or part of the history that still exists remotely, you can remove it and refetch it. So if the corrupt object is a commit or part of the history that still exists remotely, you can remove it and refetch it. So we delete the corrupt object manually. Remove.get objects, okay, and then refetch. Fetch the object from a remote repository if available. So we have, okay, so we can re-grab it from the remote repository. I understand that. Store the repository from backup if available. If you have a backup of the Git directory or the repository itself, you can restore it and overwrite the corrupted data. Clone the repository again. If the repository is corrupted beyond repair and you have access to a remote version, you can clone it again. Move or rename the current repository directory. Move your repo backup. Reclone the repository. Git clone. If the repository and you have access to a remote version, you can clone it again. So why do we have to remove or rename the current repository directory? Move your repo. To your repo backup. Explain number 4 a little bit more. Attempt to repair manually. If the missing object isn't recoverable from a remote source or backup, you can manually try to recreate the missing object. Check what type of object it is, a blob, tree, or a commit. Git cat file t, and then you pass in the object. If this fails, it confirms the object is entirely missing or unreadable. Manually recreate the missing object requires advanced Git knowledge and depends on what the object represents. Prevention tips: back up your repository regularly. Ensure you have backups of your critical repositories, especially Git directories. Avoid abrupt shutdowns. Ensure proper shutdown procedures to avoid incomplete writes to Git objects. Run disk checks. Use tools like fsck or disk repair utilities to check your file system for errors that could corrupt files. what is dangling by missing tree, etc. Okay, and then we also want to explain number for a bit further about recloning and the specific steps you took. So types of get object. A blob represents a file content, which is binary or text. So blob represents file content, binary or text. Okay. Tree represents a directory structure, references blobs and other trees. Okay. And then commit represents a snapshot of the repository at a specific point, references a tree and parent commits. Okay. Tag represents a named pointer to a specific commit, optional. A dangling object is an object, blob, tree, commit, or tag that exists in the getObjects directory but is not referenced by any other object in the repository. In simple terms, it's orphaned and not part of the reachable commit history. Dangling blob represents file content that was created but never committed. This can happen if you add a file, get add, but don't commit it and later modify or delete it. Oh, so what if so maybe I added but I didn't commit, and then I later, yeah, I'm here. Okay. Huh. So a dangling object is an object, blob, tree, commit, or tag that exists in the getObjects directory but is not referenced by any other object in the repository. In simpler terms, it is orphaned and not part of the reachable commit history. Examples of dangling objects. Dangling blob. It represents a file that was created if you get add but don't commit. So I wonder if that's what I did. I wonder if I added the. Wonder if I added this new stuff, like these new files, and then I didn't commit it. Maybe that's what happened. Because it says you staged a file using get add but then deleted it. But I don't think I've deleted it, but you know, maybe I just did something else, like not correctly. The blob for file text exists in the getObjects but is now unreachable. I don't know. I don't understand. Okay, no, I mean that kind of makes sense. There we have a dangling tree. Okay, right. So then you would want that like added file. So that becomes a dangling blob. So there's dangling blob. Yeah, this is dangling blob. It's funny. Then we have a dangling tree. A tree object that exists but isn't referenced by any commit or another tree, often caused by abandoned changes or rebases merges that weren't completed. So this is stuff that you added but never committed, and then they were removed, or something similar. And then dangling commit, a commit that is no longer part of any branch or tag. So a commit that is no longer part of any branch or tag. This can happen if you reset or delete a branch without merging it into another branch. A tag that references a commit that has been removed or is otherwise unreachable. Dangling commit. A commit that is no longer part of any branch or tag. This can happen if you reset or delete a branch. If you reset or delete a branch without merging it into another branch. Reset or delete a branch without merging it into another branch. Dangling tag, a tag that references a commit that has been removed or is otherwise unreachable. Okay, I understand the concept overall. I don't understand how some of this like could happen per se, but I understand like the dangling blob, and I understand the dangling tag. Most like the other two are a little more fuzzy to me, but anyway. So a missing object occurs when Git expects to find a specific object in its database, but the file is missing a corrupt. So missing blob created by a tree, blob referenced by a tree is missing. A file is a part of a commit, but its content blob is missing or corrupted. Missing tree commit references a tree dictionary directory structure that is missing. Example, Git cannot recreate the snapshot of a specific commit because the directory metadata is incomplete. A commit references a tree directory structure that is missing. Commit references a tree that is missing. Git cannot recreate the snapshot of a specific commit because the directory metadata is incomplete. Okay. And then missing commit, a branch references a commit that is missing. Commit history is incomplete, so Git cannot traverse the repository's history. So dangling objects, rewriting history. Commands like git rebase or git reset can create dangling commits because they rewrite history and leave old commits unreferenced. Rewriting history. Commands like git rebase or git reset can create dangling commits because they rewrite the history and leave old commits unreferenced. Okay. Uncommitted staging. Staging a file and then removing it without committing leaves a dangling blob. So that I understand. That means we added it and then either removed it explicitly or like implicitly removed it, you know, like on accident by not committing, and then just like, alright, see you later. And then yeah, strange. Okay. Now we have temporary operations. Git creates temporary objects during merges, rebases, or cherry picks. Git creates temporary operation objects during merges, rebases, or cherry picks, which may remain dangling if the operation fails or is aborted. Missing objects. File corruption. So this is what I'm dealing with. Well, what did it say explicitly? So, well, we had a lot going on actually. We had dangling, we got a lot of stuff. And I just wonder how much of this is like old and how much of this is like new. You know what I mean? Is this like all part of the same Git bug? Like, is this all happening at once, or did this just like accrue over time and then now all of a sudden one of them is actually causing it to just like not be able to function anymore? So we have missing tree, dangling blob, and dangling commit, but most everything is dangling. We do have missing. We have missing blob, and then we have missing blob, missing tree. So we have missing trees and missing blobs, missing trees and missing blobs, missing objects. File corruption. So I have had problems with my hard drive. It's cheap hard drive. It's a large, cheap hard drive. So, but it also could be my older ones. Actually, it might not be the new one. I just assume that it's the new cheap one, but it could actually be the good old ones, right? Because they are very old and they are technically like past their lifespan. So I probably should get some new ones. Maybe that's the issue. So you have file corruption, disk corruption, power loss, or incomplete file writes can cause objects to go missing, and accidental deletion, manual removal of files, and get objects. Repository cloning issues if a clone is incomplete or interrupted, object may be missing. So I have a feeling that this is hardware related. This is actually related to legitimate, like, not anything I did on Git per se, or anything that I deleted in the actual repositories, because I didn't do that. Is because of some sort of file corruption issue related to my actual my solid state disk drives. So how do we handle these issues? We handling dangling objects. We check for dangling objects. Well, we did that. Okay. Then recover dangling commit blobs. You can inspect dangling objects and potentially recover them. Show a dangling blob's content. I don't understand. Recover a dangling commit, get check out. So we have to clean up dangling objects. If you don't need dangling objects, you can clean them up using git gc. But that's not going to fix the missing objects. Clean up dangling objects. This garbage collects unreachable objects and reduces repository size. Handling missing objects. Find the problem, run full, and then it's going to tell you if you have the backups or another clone of the repository, you can manually restore the missing object. Example, copy the missing object into git objects, reclone the repository. If the repository is corrupted beyond repair, you can delete it locally, reclone from the remote. Fix corruption. If corruption is due to a specific file, you may need to manually read data. Dangling objects are unreferenced objects in your Git database and are inherently harmful. They can often be ignored or garbage collected unless you need to recover them. Missing objects are problematic because they indicate data loss or corruption, preventing Git from working correctly. Would you like to help inspecting? Okay, gotcha. So first of all, we can do git gc to garbage collect. So we're gonna do git gc. And I've never done this before. This is the first time doing this. So deletion of directory, git refs remotes, Canasta failed. Should I try again? Yes. So it's showing me that it's deleting stuff. And so this might be connected to Google Drive. Because I'm noticing so it's failing over and over again. Deletion of directory. Da 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 da. Reclone of specific sections that she took. You've hit the. I hit the max limit. Well, for the newest language model or whatever, it's gonna like send me back to the older one. Explain number 4 a bit further about recloning and specific steps you took. Sure, when facing issues like missing or corrupted Git objects are difficult to process or recover, cloning repository can often be the most straightforward solution, especially if you have access to a remote version like GitHub or Bitbucket. Here's steps on how to handle this. Steps to reclone a Git repository. Backup the current repository optional. Before proceeding with a destructive operation like deleting the repo, it's a good idea to back up your current repo. This allows you to potentially recover any uncommitted changes, stash, or patches, or inspect the current state further. So MV your repo. So this is moving your repo to your repo backup. So it says this command names your current repository folder to something like your repo backup, essentially creating a backup directory. You can now safely delete or reclone the repository while still having a backup. Okay, so you're You're basically like creating a new directory called repo backup, and it puts your current project in that directory so that whenever you do subsequent operations on your repo instead of your repo backup, you still have everything inside of your repo backup that you know you previously had. Okay, that makes sense. Then we have step 2, remove or rename the corrupted repository directory. Remove or rename the corrupted repository directory. If you don't need the corrupted repository anymore, if you've already backed it up, you can delete the old repository directory. If you simply want to keep it for reference but not use it anymore, renaming is a safer approach. If you want to keep it for reference but not use it anymore. So we delete the repository directory if you don't need anything more. So we rm rf your repo. rm and then rf your repo. Rename the repository if you still want to keep it. So then we say your if you still want to keep it. So then we're moving it basically. Okay, what is mv rm and dash rf? Step 3, reclone the repository from the remote. Now the corrupted or problematic repository is either removed or renamed, you can clone a fresh copy from the remote repo. So to do this, use git clone command with the URL of the remote repo. For example, if your repository is hosted on GitHub, it might look like this: git clone https GitHub username repo name dot git. This will create a new directory named repo name containing a fresh copy of your repository from the remote. If the repository is large or has a lot of history, this process might take a little while. A new directory named repo name containing a fresh copy of your repository remote. If the repository is large or has a lot of history, this process might take a while. And then we verify the first clone. Once the cloning process is complete, you can cd into the new repository and verify that everything is working. So then we cd to the repo name. And then git status. Ensure that your current status of the repository is fully functional, doesn't show errors regarding missing or corrupt objects. Restore local changes if needed. If you had uncommitted changes in the corrupted repository, you can now restore them from the backup or the old directory. So if we had uncommitted changes in the corrupted repository, you can now restore them from the backup or the old directory. Okay. So to copy the uncommitted files from the old repository to the new one, if we have uncommitted changes, which we do, manually copy them from the old repository to the new one. Okay, stashes. If you had stash changes in the old repo, you can transfer the stashes first. Check the list of stashes in the old repo. Okay, so we're not worried about stashes. Then apply stashes. Why reclone is effective. So how do we do the manual? How do we copy the uncommitted files? How to? Okay, why reclone is effective. Corruption prevention. If your repository's local database is corrupted, missing objects, things like reclone gets restored with a clean functional version from remote backup. The remote repository serves as a reliable backup, especially if you've pushed your latest changes there. Simplified recovery. If you can't easily recover missing objects or the corruption is too deep, cloning eliminates the need intervention to rebuild history. Easily recover missing objects or the corruption is too deep, cloning eliminates the need for manual intervention to rebuild history. Okay. What to do if you don't have a remote repository, no backup? If you don't have it, if you're working locally or have never pushed a remote, recloning won't be an option. You'll need to manually recover from backups. So restoring from local, try to verify the corruption, check for partial clones or submodules. Okay, cloning is a straightforward approach when dealing with a corrupt or problematic Git repository, especially if you have working remote. Try to start fresh with a clean copy without the need to manually recover individual objects. Would you like any additional clarification on recloning or otherwise handle restore corruption? MV is move or rename. The MV command is used to move or rename files and directories. So remove a file. So you're really creating a new directory and then placing everything inside of that directory with one command. You're really copying everything from the current directory into a new directory that you're creating. Source is the path of file or the directory you want to move. Is the path of the file or directory you want to move. Destination is where you want to move the file. Rename a file or directory. If you specify the same directory but a different name. If you specify the same directory but a different name for the destination, it effectively renames the file or directory. Move old directory to new directory. This would rename old directory to new directory. RM. So whenever they said MV your rename the repository directory if you still want to keep it. MV your repo to your old repo old. So that's just renaming your current repository. That's not actually creating a new one and copying everything to it. So then you still have the git repo at the old name of your repo. So whenever you clone to that repo, I get it. Okay, I see now. Gotcha. Giggity gotcha, babe. Alright, so where did I stop? Where are we at here? Steps for dealing. Okay, so we already did all that. RM remove. Okay, baby. RM remove. The RM command is used to remove, delete files or directories. Remove a file. Okay, this deletes file text from the current directory. Remove a directory. You need to use the R recursive to delete directories. Remove -R directory name. This removes the directory and all of its contents. Gotcha. RF flags for RM. Force and recursive. So RF or -R recursive. This flag tells RM to delete directories and their contents recursive. Without it, RM only deletes individual files and will fail to be sure to delete a directory. F force. This flag forces the removal without any confirmation prompts. It also ignores errors like trying to delete non-existent files. It's useful when you want to ensure a file or directory is removed without being asked for confirmation, even if it's write protected. Sample remove RF. Oh, so it's two flags. It's R recursive, and then F is force. Got it. Okay, I understand. Directory. This command will delete the directory name directory, recursively delete all files and subdirectories inside directory name, and enforce the deletion without asking for confirmation. Gotcha. So what was it telling me to do? What exactly did it tell me? It said to RM RF your repo. So delete the repository directory. Rename the so I want to keep it. So step one was to create a backup using move your repo to your repo backup. And then we delete their okay, so then we delete the repository. And then we clone. Okay, so we have to delete the old repository. So we're removing recursive force on the original repo. Gotcha. Gotcha. I understand. And it says, what to watch out for with RMRF. Irreversible. Once you delete something, remove RF, it's gone. It's not recoverable through normal means without backups or specific. If you do this question, always check the command for running it, especially with RF. A small mistake, like a misplaced space or wrong directory name, could delete important files or directories unintentionally. Move or rename file directories. RM is remove files or directories. rm-rf is forcefully and recursively remove so your directories and their contents without asking for a confirmation. Let me know if you'd like more details on any of these comments or examples. How to copy uncommitted files from the older repository to the new one. How to copy uncommitted files from the older repository to the new one. So we'll worry about that for after. I got 2 more minutes till break. What do we want to do here? We wanted to, step 1, we want to reclone a git repo. So we want to do mv your repo backup. So we do want to back it up. So what we're going to do, what is gc? What does it do in git gc? What is git gc? Baby, I can't remember, baby. It's gone. Anyway, inflate, error, inflate, data stream error, incorrect header check, unable to unpack, giggity, don't know what that means, fatal, loose object, scrubbed, failed to run repack, baby, that's not good, that doesn't sound good. Why, oops, we don't want to paint, oops, we don't want to paint, git branch, baby. So now we're gonna do mv, and so we should copy this. We should copy this, right? Hold up. Before I do any of this, here's what we're gonna do. We're gonna create a real local backup, baby. We're gonna create a real local backup, baby. So we're gonna go to Canasta. We're gonna go to the little Canasta. We're gonna hit that Control C, baby. We're gonna go back to the backup. We're gonna delete that old one. We're gonna paste in this new, possible corrupted version. Maybe I should have kept the backup. Well, it's okay. It'll be in the trash, so I could restore it if I need to. To text devlog, we're gonna go all the way to the end, so it should today. So now we're gonna do, there goes our time. So now we're going, okay, so now we have our new backup, which is 1.6, baby. Alright, so I'm gonna go take a break. I'm actually gonna go eat, because I think I need to eat. I'm gonna go eat. I'm gonna come back. I'm kinda tired. It's okay. I don't know why I'm so tired. I shouldn't be. I didn't really sleep good last night, so maybe that's why. Anyway, I'm gonna go eat some dinner, and we're gonna do some more coding after I'm done eating, and then continue another hour at least. Hopefully I get in 3 hours, so I'm gonna do another 2 hours. Alright, I'll see you guys shortly.